Hi everyone, Mr. Ford here yet again. I'm going to post a guided practice for page 20 of your electricity packet. It's another one of those combination circuits. After getting a request, I started to go through and make the video, and I realized that I made a mistake on the answer key, a very basic mistake on the answer key. Curiously, nobody pointed it out as of yet, but if you watch the rest of this video, you can either use it as a guided practice how to complete it, or just fast forward to the end to see the corrected answer key. So first off, this is another combination circuit. We see that resistors 3 through 7 are all in parallel with each other, so we're going to have to collapse them down. And then that would basically make this type of circuit. My drawing is horrible. Where we would see that these three, so this would be like the combination of 3 through 7, resistor 2 and resistor 8, all in series with each other, and then we would collapse them down according to the series rules, and we would have, I don't know why I'm drawing it like this, a basic parallel circuit that we then could eventually compress down to just a one resistor. So the first thing we're going to do is find the total voltage, or sorry, total resistance for resistors 3 through 7. So we're going to have to add all these according to parallel rules. So it would just be the inverse of each individual one added together, hit your equals button, and then take the inverse of that number. So all together they have 2 ohms of resistance. So that would put us here. We would have something like this. Let's change color. We'll go green. 2 ohms. Actually, I need a little bit smaller. 2 ohms here, and then resistor 2 is 8 ohms. And resistor 8 is 10 ohms. And then resistor 1 was in here with 30 ohms. So then we could collapse these. They are in series, so we simply add them together. So 8 plus 2 plus 10, you get your 20 ohms and your 30 ohms. And you add those according to parallel rules. So 1 over 30 plus 1 over 20, hit the equals button, and take the inverse, and that gives you 12 ohms of resistance total for the whole circuit. Then using Ohm's law, V equals IR, we have our 120 volts, we have our 12 ohms, simply divide, and we have our 10 amps of current. So since there's nothing directly in series with the battery, everything's essentially parallel, or we can't really fill anything as of yet. But what we can do is, usually we've been looking at current to start off. We're going to look at voltage. So since this is 120 volts at the battery, is there anything that is in series with that? So, I'm not sorry, so, parallel. So we see resistor 1 is in parallel with the battery because the current can go in this loop, or it can choose to go into that bigger loop. So since R1 is in parallel, R1 has that full 120 volts. And this is where it starts to unlock. So since for resistor 1 we have the voltage and the current, we can find, the voltage and the resistance, we can find the current. So just our 120 volts divided by 30 ohms, we get our 4 amps. So right here we have 4 amps. And the total current for the whole circuit is 10. So if we look at it as, if we highlight this here, it's really only looking at 2 resistors, where if one of them is 4, what's the other one have to be? Nice job, 6. So if this is 4 amps, 4 amps here, then this total would have to be 6 amps. So at both resistors 2 and 4, since this is like one straight line here, or looking back to here rather, it's essentially one path, so it all has to have the same current. So resistor 2 and resistor 4, which are here and here, so the 8 and the 10 that I just circled, we're going to have 6s as far as currents go. And for resistor 2 and 8, we have two of the three pieces as far as Ohm's law is concerned, so we can find out the voltages, 48 and 6 dibs and 60. So then all we're left to battle with is this segment here. So for that part, we know the total current between resistors 3, 4, 5, 6, and 7 has to be 6, because we have 6 coming through here. So 6 amps has to go through all the way through and then come out this side at the bottom. So each resistor 3 through 7, that total has to be 6. So there's a couple ways we can go about it. We can think conceptually. So when we look at 8 and 16, right, that's the resistances of these, right? We can look at it in terms of 8 being half of 16, 16 being double of 8. So really we're going to have 1, 2, 3, 4, 5 different resistors that somehow have to all add up to 6, where you can kind of jump or group them in, like being, you play the numbers game, the algebra, and figure conceptually through. But I don't think we need to do that as of yet. I think it's a little bit more difficult, and we've shown anything in this course that simple algebra is usually what leads to your demise, and mine with my wrong answer key, saying that 12 times 1.5 is 1.8 instead of being 18. Let's not look at the current. Let's look at the voltage. So let's see, pick a color. Let's see if you can guess what I pick. Let's go basic colors. This will be really cool if you get it right. I'm going to pick yellow. If we look at this circuit here, right, we know that we should do this like picking color thing more often. It's pretty cool. What am I going to pick now? Black. So we know that resistor 1, we had our 120 volts. And we know the current here, or sorry, the total here has to be 120 volts as well, because it's directly connected to the battery. But if we take a step back in what I'm boxing in now in black, those three totals, those three numbers are all in, how do I want to say this? Lost for words for a second. Oh, not these three, sorry. Just this one here. So I'm going to do orange. So we already figured out that there is 48 volts here, and then there's 60 here. So since we need to get to 120, we just find out that missing one. So it's 48 plus 60 plus some value equals our total 120 volts, and that means that it's going to be 12. So this middle part that we kind of defined as all of those resistors added together, this total voltage here is going to be 12 volts. So all of these here are 12 volts. So then you can find your missing currents at each resistors 3 through 7 using Ohm's law. And you can kind of see the conceptual aspect of seeing that we need to get up to 6. They all add up to 6. And these two, since they are twice the resistance, they get half the current. So that's what I meant by looking through the algebra and ratios, conceptually understanding current, resistance, being able to figure those out. So then it was just power, calculating all the powers in your power check. This was my demise. It should be 18 volts for these ones, or 18 watts, and not the 1.8 that I initially suggested. And that would give us exactly this 1200, not the 1151 that I initially said. So hopefully that makes sense. If not, send me a Schoology message. Don't forget that helps. I can be available to you guys most of the times during the day. And we have our sign-ups during class times and my office hours. Just click the link on Schoology and request a time. All right, have a great day.